Hi guys, welcome to my YouTube channel. Today I'm going to be explaining 4 important set theories. Actually, I'm going to be proving in better terms. Okay, so now let us start. The first one is A union A is equal to A intersection A. Now it's called idempotent. You can just, since I said important set theories, you can just link both of them. Important, idempotent. Maybe use it to remember it. Okay, let's go. Now let us prove it. Let's set A equal, I'm just going to pick on random elements now. Let's say 1, 2 and 3. Okay, now since now we're going to look for this one first before we look for this one. All right, now A union A is equal to A union A will still be equal to this same element, because the union is just all the elements in the set that you're looking for the union of. For example, if you're looking for the union of A and B, different sets, you're just going to put all the sets of A and B together. Okay, now the intersection of two sets, you're going to write down the alike terms, okay, in the set. So let's go. A intersection A. Okay, now 1 is in A, 1 is also in A, 2 is in A, 2 is also in A, 3 is in A. So there you have it. 1, 2, 3. I guess it's simple as I proved idempotent. Alright, let's go to this one. A union B is equal to B union A, or A intersection B is equal to B intersection A. It's commutative. Now, one thing I want you to know is that in sets, this guy doesn't really matter. This dude, arrangement. Yeah, Mr. Arrangement doesn't matter a lot in set. As far as they have the same elements, yeah, they are the same sets. Even if set Q is equal to, okay, let me do the bracket very well. Set bracket 1, 3, 5, and set Z is equal to 5, 1, 3. They are the same thing. They are subsets of one another. Don't worry. In my main set video, I'll be explaining this. But now let me move to B. Now, I've already given a set of elements. Now let me give B this. Let B's element be equal to A, B, C. Now notice I used small letters here so that we won't get confused. These are small letters. In this now, they are different from the big letters. Okay? Alright? These are elements. This is a set. Alright? Let me continue. Now, A union B is simply equal to A union B is equal to what? 1, 2, 3, A, B, C. Okay? Now, B union A is equal to what? A, B, C, 1, 2, 3. Now, remember I told you this guy doesn't matter, which means this is still the same as this. If you do the same for intersection 2, you will find it to be true. How would I give you that as an assignment? Okay, let's go to row 3, should we? Alright, row 3, this. Okay, A intersection B, open bracket, B intersection C is equal to A intersection B, close bracket, intersection C. Okay? Alright, now this one, it's called an associative what? Associative theory. Alright, now let us continue. Okay, now that I've given A, where is it? A some elements. I've also given B some elements. Hey, why can't I give C some elements, right? Now you might be wondering, oh, you gave A numbers, B letters, then what can I give C? Now, watch out, because these letters, I can decide to give C D, E, F. It's actually DFE normally. Alright. Actually, it can be EFD, EDF, anyone you want it to be. But I can write it as EFD normally, anyone at all. Okay? Alright. So, let me continue. Now, I've given C, D, E, F. Alright? Now, what I'm trying to do here is that I will actually prove this third law. Okay? So, A intersection B intersection C. Let's get that, should we? Now, when you have a question like this, A intersection B intersection C. Now, what you're going to do is that you're going to want to solve the one in the brackets first. Remember? Board mass. Okay? So, now the one in the bracket is B intersection C now. Alright? So let's have our B intersection C right here. So now, B intersection C will be equal to, let me see, A, B, C. Remember, A, B, C. Okay, B intersection C. I'm very sorry. Intersection means alike elements, which means B intersection C is going to be a null set. Okay? B intersection C is going to be a null set there because they have no alike, alike elements. So A intersection B intersection C is also going to be a null set. Alright? So let me move on. Now let us see if this also gives us a null set, should we? Let us look at the elements in A. 1, 2, 3, A, B, C. It's also a null set, which means that this law has also been proven. You do the same thing for the union of this, you will also get it. Alright? So let us move to the fourth law. Now the fourth law, I'm not actually going to solve it, prove it this way. I'm going to prove it in a different kind of way. Okay? In different manner. Let me just write it here. That will be okay. Now we have this. Alright? So now let me quickly prove it. Okay, now let X be an element of A. Okay? Let X be an element of A, and let X be an element of A intersection B union C. Okay? Now let that be it. Now, I actually made X an element of A and X an element of this for a great purpose, to prove this. Now, it's not compulsory it's X. I could have used another letter. But let's move on, should we? Okay? Now, anytime I see an element like this, I mean a set like this, I'm going to add X is an element of. Okay? In order to prove this law, I'm going to be using this to prove this. You can see I'm going to be turning this into this. I'm going to be turning this into this. So, let's continue. Now, X is an element of A. Okay? We know that. Now, where you see intersection, it means and. Because remember, if A intersection B is equal to 4, it means that 4 is an element of A and B. So, and X is an element of B, or X is an element of C. Now, we normally denote sets with small elements with small letters. So, this is supposed to be a small letter, but because I'm writing it, you understand? So, now the reason I put all here is that remember that for union, you just mash all the elements together. So, it means that since A union B since A intersection B union C can be equal to X, it means one of these two must have X as its element. Okay, so that should mean that X should either be an element of A and should be an element of B, or X should be an element of A and an element of C. Okay, now we have already got into our answer, because X should be an element of A and an element of B, or X should be an element of A and an element of C. Don't worry, I'll do a quick recap. Alright, so now remember, anywhere you see and, it means intersection. Anywhere you see or, it means union. So simply removing this X is an element of, X is an element of, X is an element of, and interchanging and changing these with their union and intersection, respectively, whatever. So now you have A intersection B union A intersection C. Let me do that quick recap I spoke about. Okay, so since X is an element of A and X is an element of this, it means that X is an element of A. X is also an element of this. It means that since X is an element of A and one of these two, that's why I go to X is an element of A and X is an element of B, or X is an element of A and X is an element of C. Now simply removing this X is an element of and changing this and to intersection and changing the or to union, we get this, which is also this. So this one has also been proven. Please like and subscribe, and please don't forget to write your comments, because I really want to know what you think about this video. All right, thank you very much, guys. Take care of yourselves.